Hello, this is Geometry 8.1, similar polygons. So remember when we were talking about dilations? Dilations actually create similar figures. So if two figures are similar, two things have to be true. All the corresponding angles are congruent, but then the corresponding sides would be in proportion. So let's just say I start with a triangle, ABC, and I dilate that triangle with a scale factor K of 2. Then that triangle enlarges where each of the corresponding sides are twice as long as the pre-image. Instead of using prime notation, I'm going to call this triangle DEF, but all the corresponding angles have to be congruent. So what that means is angle A is congruent to angle D, angle B is congruent with angle E, and then angle C is congruent with angle F. And let's just say you knew the side length B is 3 units in length. If the scale factor is 2, side EF corresponds with that side. So you would just multiply 3 by 2 to get a side length EF of 6. And then I could write a similarity statement for those two triangles. It's kind of like when we were writing congruent statements for two triangles. There's a certain order that you have to write things in. I could say triangle ABC, and that sets the order for the second triangle. I could have started this in any way. I could have made it triangle BAC, triangle CAB, anything like that. But as soon as I start and set the order, now the second triangle that's similar with it can only be written one way. The symbol right here, the little squiggly mark, is a symbol for similarity. It's like congruence, except without the equal sign underneath it. But ABC, that triangle is similar to A corresponds with D, B corresponds with E, and then C corresponds with F. So that's a correct similarity statement that I could write. It's not the only correct one, but it is a correct similarity statement. Next, I want to take a look at the perimeter of similar polygons. So if I start off with a rectangle, say a 2 by 3 rectangle, and dilate that with a scale factor of 4, I would definitely come up with an enlargement. This is definitely not to scale. It should be the case that each of the corresponding sides are 4 times as long. But the side that corresponds with 2 units would become 8 units. The side that corresponds with 3, multiply that by 4, would become 12 units. So we could figure out the perimeter fairly easily of the smaller rectangle, 2 plus 3, 5, and then times 2. So the perimeter would be 10. The perimeter of the larger rectangle, 8 plus 12, 20, and then times 2 because this side would be 8, this side would be 12. The perimeter is 40. And see how the perimeter of the enlargement or the image compares to the pre-image. The perimeter is 4 times as much. So that leads to Theorem 8.1. Then Theorem 8.1, the perimeter of similar polygons theorem, states if two polygons are similar, like we have for these two polygons, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. It's also equal to the scale factor. So the ratio of the perimeters, larger to the smaller, the image to the pre-image, 40 to 10, that's 4 over 1, is equal to the ratio of the corresponding sides. It could be equal to 8 over 2, that's still 4 over 1. It could also be equal to 12 over 3, that's still 4 over 1. It could also be this scale factor, 4 or 4 to 1. All of those are equal, 4 to 1.